Hello everyone. So in this class or in this lecture, we will be discussing about the concept of Hamiltonian cycle. It is one of the application of backtracking, and it is largely used in map routing, protein band analysis, as well as it is also used in robotics applications. So it's a concept based on graph, which is collection of vertices and edges. And the idea is to create a cycle starting from a source vertex, traveling all the vertices and ending back to the source vertex. So the constraint here is to visit all the vertices given in the graph. So as the idea is, it is a cycle generated on the graph with same vertex as source and destination. And the constraint, very important, is each vertex has to be visited once. And if you are using a edge, then it can be also used only once. But it is compulsory to visit each and every vertex of the graph. So suppose there are 5 vertices in the graph, then one of them will be source, and again the same will be source, and remaining vertices will be the intermediates. So if there is for example, we can have one as a source, 3, 4, 2, and 5, and then it will end with 1. So you can take it as a cycle 1 to 3, 3 to 4, 4 to 2, 2 to 5, and 5 to 1. It is also possible to skip some of the edges. So one of the application is traveling salesman's problem also. So let us try to apply the logic of Hamiltonian cycle on this graph. This is a graph with 8 vertices, assuming that vertex 1 is source. So in this whole process, it is first necessary to find out how many possible cycles. For example, vertex 1 is connected with 2, then 3, and then 7. So in this case, there can be 3 cycles possibly from vertex 1. And if you look at vertex 3, then it is connected with 1, 2, 4, and 6. So possibly there can be 4 cycles. Now it is essential to determine whether there really exist these 3 cycles or really exist these 4 cycles. So that we are trying to check through a normal brute force, and then we will try to apply the backtracking concept. So if I start with vertex 1, then there can be 3 possible paths: 1 to 2, 1 to 3, and 1 to 7. And now we are trying to check whether there exists a cycle from each of these 3. So let us take 1, then 3, then 4, then 5, 6, 7, 8, 2, 1. So this is starting with 1, visiting all the vertices once, and again ending with 1. Similarly, if you take 1 and if you travel to 2, then you can travel to 3, 4, 5, 6, and then 7, and then 8. But again, 1 is repeated. So 1 to 2 was basically augmented by 3 as the next vertex. So So now the point is when you continue from vertex 2 to 3, it is not generating a cycle. So let us try to check whether it is possible to continue further 1 to 2. Let's start with 2 to 8. That is another option. So 8 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3, and 3 to 1. So now we are getting all the vertices visited once, and the cycle starts and ends with 1. So this is another cycle which has 2 as the next vertex, and this is one more which has 3 as the next vertex. Let us try for another version, that is 1 to 7. So if you start with 1, go to 7, there are options like 6, 8, and 1 is not allowed. So let us continue with 8, then 2, then 3, then 4, then 5, then 6. And now again we are stuck up because it will again come back to 7. So in this case, we will be visiting 7 twice to reach to 1. That is not allowed. So again 1, 7, and after that go to 6, 5, 4, 3, 2, 8, and stuck up. So this is an indicator that when we have tried both the options from 7 and we continued further, the cycle is not seen. This means that there are only 2 cycles from vertex 1, although there are 3 connections from vertex 1. Uh, Same idea can be applied on the next vertex, that is vertex 3. So one conclusion here is vertex 1 has only 2 cycles. Let us try to check whether there can be 2 or more than 2 cycles from vertex 3. So if you write vertex 3, it is vertex 3 to vertex 4 to 5 to 6 to 7, then to 8, then to 2, and then to 1, and then to 3. So this is one possible option. If you try from vertex 3 to vertex 2, then we can write 3 to 2, 2 to 1. Okay, maybe 3 to 2, 2 to 1, 1 to 7, 7 to 6, 5, 4, 3, and 2. So in this case, we are not able to visit a vertex 8. Let us try for another version of vertex 3. So that is vertex 3 to 1. So if you look at this idea, we have already created 1 to 3, and now we are trying 3 to 1. So there must be a cycle if you try from 3 to 1. 3, 1, then you can take 1 to what? So 3 to 1, then 1 to 2, 2 to 8, 8 to 7, 7 to 6, 6 to 5, 5 to 4, and 4 to 3. So this is one more cycle. So we tried vertex 4, vertex 2, and vertex 1. And let us try vertex 6. So 3 to 6, 6 to 5, 5 to 4. This is one option. Block stuck. 3 to 6, 6 to 7, 7 to 8, 8 to 2, 2 to 1, 1 to 3. Again stuck because 3 is visited and 4 is not visited. So it is again the same point which I am trying to explain through vertex 1 and vertex 3, that once you prove that there is one cycle or there are X number of cycles from a particular vertex in a graph, This property will be valid for each and every vertex in the graph, mostly. Okay. So that is the idea of Hamiltonian cycle. We'll continue with this in the next video. Thank you.